Hi everyone, welcome back to Cody's Lab. So you might have seen those scale models of the solar system where somebody takes a football field and they mark out where all the planets are. Well, I want to try doing something similar today, but include the nearest stars to the sun. So like Alpha Centauri and Proxima Centauri, those stars like that. So I've got a bag here with some stars and planets, a tape measure. Let's go set it up. So we've come here to the Grantsville High School football field and we're going to start the scale model here. For the sun, I'm going to be using a P. The reason I'm going to be using a P is because the sun, from our perspective here on the Earth, appears to be about the same size as a pea held at arm's length. So I can almost exactly block out the sun's light using a P held at arm's length. Or more accurately, a 7mm wide P held at 70 centimeters away. So set this on my little card here. So here's our 7mm wide sun. Now keep in mind that in real life the sun is 800,000 miles or 1,300,000 kilometers wide. So on this scale the Earth would be 2.3 feet or 70 centimeters from the sun. So you might notice that the Earth and the Moon here are actually too small to be noticeable on this scale. So use a magnifying lens to zoom in and you can see there are indeed dots there. It's the Earth and the Moon, and the distance between them, 240,000 miles, is about 1/4 of the diameter of the sun. So before I continue, I want to mention real quick how I know these distances. You see, Venus is about 3/4 of the way between the Earth and the sun, and Venus occasionally crosses in front of the sun. Now from the orbital period of Venus and the Earth and Kepler's laws, we knew that the ratio was about 3/4 of the way. But we didn't know an actual number until we could observe a Venus transit. And then from viewing the Venus transit from two different positions on the Earth that are widely spaced, we could see the parallax shift of Venus relative to the sun. And from that, we could do some geometry and trigonometry and figure out the exact distance between the Earth and the sun. Once we found out the astronomical unit, we could use that to get another parallax shift between the nearest stars and some really distant stars to figure out how far they were. This measurement was actually a linchpin in science of figuring out how big the solar system and the rest of the universe was. Okay, so the next object that I'm going to put on this scale is Jupiter, which here is represented by a poppy seed. That's approximately the size it needs to be relative to the sun if the sun was a pea. So at this scale, Jupiter will be about 4 meters from the sun or 12.8 feet. And 12.8 right there. So that's where our Jupiter is. So the next object I'm going to put on this scale is Pluto, everybody's favorite minor planet. Now, of course, on this scale it's also a dot that's too small to really see on camera, but it will be 97 feet or 30 meters from the sun. Right about here. So around 97 feet from our P sun is the tiny speck of Pluto where the New Horizons probe just passed. The next object I'm going to put on this scale is the Voyager 1 probe, which is currently the farthest man-made object away from the Earth. I'm going to have to go out kind of a ways for this one. Right here, 317 feet from the sun, if the sun was a pea. That is almost all the way across the football field here. Now even at this scale, to mark where the nearest star is, we're going to have to leave town. Did I say leave town? I meant leave the state. We're here just outside of Downley, Idaho, and across the street from Donata Hot Springs. And here is where Proxima Centauri, or the closest star, would be located on our scale. If the sun was a pea, Proxima would be a radish seed, 202 kilometers or 125 miles away. Proxima b, the nearest known exoplanet to our own solar system, it'd be a tiny speck right there, about 3.5 centimeters from Proxima Centauri. Proxima Centauri is a red dwarf star. It's very dim, so in order to be in the habitable zone, Proxima b has to be quite a lot closer than the Earth is to the Sun. This also means that Proxima Centauri is too dim to be visible in our night sky, at least to the naked eye. Of course, in order to get to the nearest visible star, we've got a little while longer to go. So we're now just on the other side of Downey, Idaho, just a little ways up the road really, and I have here Alpha Centauri, the nearest sun-like star to our own. And it is actually slightly larger, so it's represented here by a slightly larger P. Alpha Centauri is one of the brightest stars in the sky. It is certainly visible from the Earth. It seems kind of crazy that something this small could be visible from so far away, but you gotta remember that stars are incredibly bright for their size. In fact, if this thing was shining, it would outdo an arc welder. What's kind of cool about this demonstration is in order to block the starlight from Alpha Centauri exactly, block it out so that you can see if there's any planets around it, so that the glare is not blinding your telescope, you would have to hold this P 208 kilometers away. In fact, if you wanted to do that, you would really need to have a much larger disk, something larger than the diameter of the aperture of your telescope, and then you'd have to hold it even farther away. Anyway, Alpha Centauri is not alone. In fact, it is part of a double star system. 25.25 feet away, or about 7.7 meters, is Beta Centauri, a star which is slightly smaller than our own sun, so is represented here by a slightly smaller P. These two stars we know are orbiting each other because we can actually watch them rotating around a central point. Proxima Centauri it's kind of far away for us to be certain that it is gravitationally bound to the system, so we're not entirely sure if it is a three-star system, but that is fairly close in stellar terms, so it's likely that Proxima is part of this system. So there you have it, the nearest stars to us other than the sun. Kind of gives you an idea of just how big space is. At this scale, we were traveling the length of our entire solar system every couple of seconds for the last 3 hours to get here. The stuff in space is just crazy far. In fact, there's a video in the description that kind of describes how far away it is. It's the theme song to the 365 Days of Astronomy podcast that I listened to a few years ago and rather enjoyed. I'm sure you guys will bring up the Breakthrough Starshot project that aims to get a spacecraft to these nearest stars within 20 years or so. Well, it's not impossible, but you can see the challenges they're facing. And I really hope they're able to do it because I'd love to be able to see these stars from this close up, for real. And if you guys want to know about some other close stars, well, there's Sirius, the brightest star in the sky, which would be about the size of a marble, such as this. But it would be about this much farther away and in a different direction, so I didn't really want to drive that far today. And Betelgeuse, the star that Ford Prefect is from near the vicinity of, is a red supergiant, which would be about the size of a car. And in order to position it on this scale, you would have to put it somewhere on the east coast of the United States. And that is going to the east coast of the United States, passing it, going all the way through Europe, Asia, back around across the Pacific Ocean, and then back to the east coast of the United States. That's kind of how far we're dealing with here. But that is one of the farthest distant stars that are visible to our eyes, and Betelgeuse is quite bright. Most of the visible stars are within a few hundred light years of the Earth, and keep in mind our galaxy, which contains trillions of stars, is hundreds of thousands of light years wide, and is only one of billions of galaxies. Anyway, hope you enjoyed. I'll see you next time.